Medicines are extremely essential to many people across the globe. Today, nearly 70% of Americans are taking at least one prescription drug. With the number of prescription medications on the rise, it is important to ensure that each person receives the most effective form of medication. However, this is right where the problem resides. Medicine has been designed for a generalized public with a notion that it should be somewhat effective for each person that it is prescribed to. The grand challenge for engineers is to develop more personalized medicines, treatments, and clinical systems so that it is more effective for each individual.
Generic medicines are primarily used today, even though it is apparent that medicines personalized to best fit people's needs will be much more effective. Why is this? Well, vast amounts of time and energy would be required to personalize these methods for specific people. The time spent would be better utilized on diagnosing other patients, and the energy spent would be better used to create more generic medicines to keep the majority of people healthy. This is currently the most efficient way of doing things, and the doctors will just continue to find more and more widespread solutions to problems so that the losses can be kept to a minimum. Engineering is currently applied to this area. They find the most efficient way to treat a large number of people. This has led to the mass production of generic medicines and solutions to treat diagnoses.
There are many potential engineering solutions to develop more personalized medications and treatments. Three of the main solutions we will look at are protein engineering, nanomedicine, and magnetic hyperthermia. Protein engineering is focused around developing enzymes to treat bacterial infections at an individual level. Nanomedicine is trying to make therapeutic substances that will cure diseased tissues. For example, depositing nanoparticles into tumors without causing any unnecessary damage, and then activating the drugs. A third approach is magnetic hyperthermia, which entails coating a nanoparticle with iron oxide and heating it to destroy cancer. There are challenges that follow alongside this possible solution. First of all, we need to be able to put tumor-specific antibodies into the nanoparticles. Secondly, the nanoparticles have to be able to find and attach to the tumors. Ideally, we would then be able to use MRI to verify that the nanoparticles have found the tumors and magnetically heat them to destroy it.
In the end, engineers are tasked with two main projects. The first is to find, through research and trials, a way to make medicine that is prescribed on an individual basis. The second task is to make this type of medicine and treatment affordable to all. That is how this challenge becomes grand. It must improve the lives of many people, and the only way for that to happen is if the future medicines are accessible by